In this video, we are going to dive into the science behind how medicines are metabolized and where CYP3A fits into that journey. If you've already met CYP3A, you'll know it's one of the hardest working enzymes in the body. But what exactly is it doing, and why does it matter? When a medicine enters the body, it goes through a process known as ADME, absorption, distribution, metabolism, and excretion. In this video, we'll be focusing on metabolism, the stage where the body chemically modifies a drug. This chemical transformation is known as biotransformation, and it mostly takes place in the liver, although other major organs such as the gut, lungs, and kidneys also play a role. Many medicines are originally lipophilic, meaning fat-soluble, which helps them pass through cell membranes, but to be excreted from the body, they must become hydrophilic, meaning water-soluble. Biotransformation serves two main purposes. The first is to make the drug more water-soluble, so it can be excreted in urine or bile, and to reduce its ability to diffuse back into cells. The second is to modify the drug's activity. Often this means deactivating it, preparing it for removal, but not always. Sometimes, biotransformation activates a drug, as with prodrugs that need to be converted into their active form. And in other cases, the process creates metabolites that remain active, continuing to produce therapeutic or sometimes unwanted effects even after the parent drug has changed. Biotransformation happens in two stages, phase 1 and phase 2 reactions. The CYP450 superfamily enzymes, including CYP3A, are responsible for phase 1 reactions. These involve chemical processes to introduce or expose reactive groups on the drug molecule. Common phase 1 reactions include oxidation, the gain of oxygen to the molecule; reduction, the loss of oxygen from the molecule; hydroxylation, the addition of an OH group; and dealkylation, the removal of alkyl groups from nitrogen atoms. Let's look at an example. CYP3A4 metabolizes midazolam through hydroxylation, forming 1-hydroxymidazolam, a more water-soluble metabolite. This chemical change helps the body eliminate it more efficiently. After phase 1, many drugs undergo phase 2 reactions, like glucuronidation, where bulky polar groups are attached to further enhance solubility. Phase 1 prepares the drug. Phase 2 finishes the job. Back to CYP3A. The CYP3A family includes CYP3A4, CYP3A5, CYP3A7, and CYP3A43. Of these, CYP3A4 is the most active and clinically significant, responsible for the metabolism of at least a third of all prescribed medicines. CYP3A4 catalyzes key metabolic reactions such as hydroxylation, N and O dealkylation, epoxidation. By introducing these chemical changes, CYP3A4 helps ensure that drugs are safely processed, deactivated or activated, and eventually eliminated from the body. So when you prescribe a medicine, remember, CYP3A4 might be busy behind the scenes, helping it reach or leave its target.